In this video, we will see how to write electron configuration using SPDF method. According to Bohr model, electrons are moving around the nucleus like planets around the sun in a fixed path called orbits or shells, or it's also called energy levels. We call it energy levels because each energy level has different energy that separates one level from another. Energy level or orbits are represented by the letter n, the small letter n, as shown in the diagram. When electrons move from one energy level to another, it absorbs or emits energy. This is the basic principle of flame test and fireworks that gives out light with a specific color that corresponds a specific wavelength. Principal energy levels are 1, 2, 3, n equal 1, n equal 2, n equal 3, like that. It goes up to 7 because there are 7 periods. Energy increases as the shell is far away. So energy increases from 1 through 7, which is away from the nucleus. Means energy of first energy level is less than energy of second energy level, and energy which is less than energy of third energy level, so on. Bohr model is found to work only for hydrogen atom. Later on, scientists found that electrons are not moving around the nucleus in a fixed path like Bohr's model. Rather, electrons are found in a region around the nucleus which is called an orbital. So an orbital is a region around the nucleus where there is high probability of finding an electron. An orbital can accommodate maximum of 2 electrons. There are different number of orbitals in each sublevel, and there are 4 types of sublevels designated as S, P, D, and F. The simplest sublevel is S sublevel, and it is spherical in shape and it can hold up to 2 electrons. And the second one is the dumbbell shaped p orbital, and it can hold up to 6 electrons because we have 3 orbitals here and each orbital can hold 2 electrons. And the next one is d sublevel, which can hold up to 10 electrons because it has 1, 2, 3, 4, 5 orbitals, and each one can hold 2, so 5 times 2 is 10 electrons. And the next one is F sublevel, which can hold up to 14 electrons because it has 7 orbitals, and 7 times 2 is 14 electrons. And in all levels, in the main levels, we can find the s orbital, but p starts only from the second energy level, that is second main shell, and d starts from the third energy shell or third energy level, and f starts from the fourth energy level, like this. So in the first one you can find S, second one also you can find S, third and fourth also you can find S. So in all main energy level you can find the S, but P starts from the second onwards, D third onwards, and F fourth onwards. To summarize, first energy level has only s orbital and can hold maximum 2 electrons. Second energy level has s and p orbital and can hold maximum 8 electrons. Third energy level has s, p and d with a total of 18 electrons, and now the fourth energy level, it has S, P, D and F and a total of 32 electrons. Now, the way electrons are distributed in an atom is called electron configuration. We have to follow certain rules to distribute electrons in an atom. So the rules are Aufbau principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. The first rule says Aufbau principle, that is the building up principle. So that means it should go first in the 1s orbital and then it will go in 2s orbital, and then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and 4f, 5d, 6p, and 7s. It's not that hard to remember because look at that. There are 7 periods in the periodic table. So we are writing from 1 through 7, and all has s orbital because it starts from the first energy level. And p orbital starts from the second energy level. You can see that there is no p orbital here, only from second energy level. So 2 through 6 we write. You can write even 7, that's not a problem, but we are just interested in this one. 2p, 3p, 4p, 5p, and 6p. And now d orbital starts from the third energy level. So 3d, 4d, 5d, and fourth energy level. F orbital starts from fourth energy level. And then just put a diagonal line across it. So the straight line parallel, you can see. Then you can remember the order. It's not that hard. And you should know how many electron each one hold. S can hold maximum 2. P can hold maximum 6. This is 10 and this is 14. And now Pauli's exclusion principle, at most 2 electrons per orbital with opposite spin. I'll show you what that means. You see that in Pauli's exclusion principle, it says it cannot have both arrows upward or it cannot have both arrows downward. One should be up and the other one should be down. So this is wrong representation because of this one, but this is the correct representation. Everything you can see that up and down. And now Hertz's rule says when electrons occupy orbitals of equal energy, that means 1, 2, 3 like that, equal energy, first single occupation takes place and then double occupation takes place. That means it cannot actually pair up before it is singly occupied. We will see an example. Here it is. See that instead of putting both the electrons in one orbital here, it is split up into 2px and 2py. Then if we have one more, it will go in the third one. Then fourth one only can pair up. That's what it means. The most stable electron configuration with the lowest possible energy is called the ground state. That's a normal one we are using. We can represent the electron configuration by a number denoting the energy level. So here 4 is the energy level. A symbol denoting the type of orbital. So here P is the type of orbital. And what is that 5 indicates? A superscript denoting the number of electron in those orbital. That's the way we are representing. And now we can represent the electron configuration in a different way. Let's say by orbital diagram. Okay, in this representation, which we call orbital diagram, each orbital is denoted by a box. Look at that, and each electron by a half arrow. In the first box, we have paired electron with opposite spin, and in the second, we have unpaired electron with a spin up. This is for lithium. So this is called orbital representation. So let us see the electron configuration for phosphorus. So if you look in the periodic table, we can see that there are 15 electrons. From the atomic number, we can count the number of electrons as well. So the first electron will go in the first orbital. You see that? 1s orbital. And the second electrons can also go in there because s orbital can hold maximum 2 electrons. So the first 2 electrons go in the first orbital. Notice the opposite spin. And now how many more we have? 13 more left out of 15, right? So the next electron go in the 2s orbital. Only 11 more left now, okay? Where is it going? Can you guess? Yes, in 2p, right? The next 2 electrons go into 2px, then 2py, and then 2pz. So how many more left? Only 5 more left. That goes from the 5, 2 goes into 3s, and then only 3 more left. Can you guess where is it going? Of course in 3p, but how will you fill it? You see, we have to fill it unpaired electron in each orbital. The last 3 electrons go into the 3p orbital. They each go into separate orbitals with the same energy, 3 unpaired electrons. So we will write the orbital electron configuration 1s2, 2s2, 2p6, 3s2, 3p3. The electron configuration can be written using this arrow method as well. You can memorize just writing the SPDF orbital in order and putting the diagonal arrow. So 1s2, then 2s2, then 2p6 and 3s2. After 3p, 4s is filled and it's not 3d due to the difference in energy between these two orbitals. Electron configuration for an element with 38 electrons, and follow this order for any other element. To summarize, first determine how many electrons are in the atom and then arrange the energy sublevels according to increasing energy. Hope you have an understanding of the basics of electron configuration using SPDF method, and now practice a lot of examples to master it.